Section 5.4 is more about the irrational numbers. This is part 2 of a two-part video series with this section. Example 1 says to perform the indicated operation and to simplify the answer when possible. So in the last video, we were multiplying and dividing these square root irrational numbers, which really are just, if we typed them into a calculator, these yucky decimals. They're just random decimals that never end, nor do they have a pattern to them. What makes them tricky in math is we're not allowed to just round the decimal answer. We have to keep the square root symbol and just simplify any portion of the number under the square root symbol if we can. Multiplying and dividing the square root numbers, we were allowed to multiply and divide them even if they had different numbers under the square root symbol. Well, not the case, unfortunately, when we're adding and subtracting. So A says 4 square root of 2 minus 5 square root of 2 plus 8 square root of 2. Kind of like with algebra, with letters, we had to have the same exact letter before we could add or subtract it. It's kind of the same idea here. So if I had the same example in algebra, if I had 4x, I'm going to call square root of 2x, minus 5x plus 8x. So I kept all those coefficients, those numbers in front the same. I'd say, okay, well, I can keep like with like. And I do the 4 minus the 5, which would give me negative 1x. And I'd bring down the plus 8x. And then I do negative 1 plus 8. Which would give me positive 7x, because really you were just counting up x's. Same idea here, but now we're counting up square root of 2's. It just looks worse with the square root numbers, but it's the same process at least. I can jump right in and I can start adding and subtracting the numbers in front because I have the same exact number under all the square roots. I have a 2 under there. So just keep bringing down the square root of 2 as you count them. So looking at the numbers in front, just like if this were an x, we had 4 minus the 5 again, which is negative 1. Square root of 2's, bring down the plus 8 square root of 2 on the end. And now I do negative 1 plus the 8, which gives me positive 7. Bring over the square root of 2's. So in other words, my final answer is 7 times the square root of 2. You'll notice I left a lot more room to write for B because B is going to be a little bit more work. B, we have 1/5 square root of 300 minus 2/3 square root of 27. I see a subtraction symbol. Remember, we cannot jump right into adding and subtracting unless we have the same exact number under the square roots, and we do not. We have a 300 and a 27 under the square roots. So this is going to have an extra step right at the beginning that part A did not have. And that extra step is to draw a good old factor tree for both square roots. See if you can simplify them down so that they do have the same number under the square root symbols, and then we can go further. So off to the side, I'm going to start by drawing a factor tree for 300. 300, pick a pair when multiplied together gives you 300. I'm going to go with 10 and 30. 10 goes down further. Remember, you're done once you have all prime circled numbers at the ends of the branches here. 10 goes down into 2 and 5, so that's done. For 30, I'm going to go with 6 and 5, so the 5 branches done. 6 goes down, though, into 2 and 3. You can go further if you have a matching pair, and we got a couple of matching pairs of numbers. I'm seeing a matching pair of 2's and a matching pair of 5's. So 300, the square root of 300, rather, is going to simplify down further, meaning I'm going to be able to apply the square root to at least some of the number. If I type in the square root of 300, it's just some yucky decimal number, but I can at least apply the square root to some of the number. Now let's just do a factor tree, though, for the 27 as well. So 27, I'm going to use 3 and 9 here. 3 is done. and 9 goes down into 3 and 3. Looking at my completed factor tree, I do have a matching pair of 3s. That one is also going to go down further. Let me go ahead and just draw a little divider here. So now we're going to rewrite our numbers using these factor trees. So equals, I'm going to bring down the 1/5, leave a little bit of room, and I'm going to rewrite 300 using the circled numbers on its factor tree. That's 2 times 2, I'm trying to go in order, times I have a 3, times I have 2 5s. Two times 2 times 3 times 5 times 5. There we go. And now I'm going to erase to create some room since I'm done with the 300 square root anyway. And bring down your minus symbol. Bring down your 2/3. Leave a little bit of space between that number and the square root symbol. And now let's rewrite 27 using the circled prime numbers from its factor tree. We have 3 3s, so that's 3 times 3 times 3. And I'm done with that factor tree, so I'm going to erase it as well. For every circled matching pair, kick out one of that number. So going back to the first square root symbol, I have a matching pair of 2, so one number 2 is going to be multiplied by the 1/5 that's already out there. I also have a matching pair of 5s. So let's see if I can fit it in with my big old handwriting. I'm going to have to kind of slant it, but times 5, so 1 5 goes out to represent the matching pair of 5s. For the second square root, I have a matching pair of 3s. So one number 3 is going to come out and be multiplied by the 2/3. Okay, and if you're not a fan of fractions, you can type the whole thing into the calculator. So here I got 1/5 times 2 times 5. If you type it all in, 1 divided by 5 times 2 times 5, you see that that does give you 2. If you do it longhand, this is actually saying 1/5 times. You can rewrite 2 as 2 over 1. You can rewrite 5 as 5 over 1. Going across the tops, 1 times 2 times 5 is 10. On the bottom, 5 times 1 is 5. 10 over 5 simplifies down to 2. So either way you do it, on the calculator or longhand, when you multiply this mess of numbers right here is what I'm doing, you do just get an answer of 2. What's left under the square root symbol? Well, just this little itty bitty 3 right there. So bring down the 3. Minus. Now we're going to do 2/3 times 3, which is really 2/3 times 3 over 1. 2 times the 3 on top gives me 6. 3 times the 1 on the bottom is obviously 3. 6 divided by 3 is 2. So you just get an answer of 2. Or type it into the calculator again. 2 divided by 3 times 3. Hit enter. You're going to get 2 doing it that way as well. What's left under the square root symbol is just one little 3 there under the square root. So now that we've simplified, check out our numbers under the square root symbols. They match. Square root of 3, square root of 3. Since they match, I'm allowed to subtract finally. Yay! So looking at the numbers in front, 2 minus 2 is 0. Bring down what you're counting. You're counting square root of 3's. So I technically have 0 square root of 3's. Just like if I said 2x minus 2x, that equals 0. 0 times square root of 3, well, 0 times anything is just 0. I know we did all that work for a final answer of 0. But yeah, 2 root 3 minus 2 root 3 is none of them left. So 0 is our final answer for part B. I know these ones are a little bit trickier until you get the hang of it, so I'd like to try one more. Here's part C. We got 3 square root of 75 plus 2 square root of 12 minus 2 square root of 48. I know, I wish we could just type it into the calculator and hit enter, but that would give us a rounded decimal, and we don't want that. We want the exact answers in math. So, step 1, I'm going to have to do a factor tree for every single number under the square root. Why? Because I'm not allowed to add or subtract square roots unless I have the same exact number under all the square root symbols, and I don't. We got square root of 75, square root of 12, square root of 48. Definitely no matches yet. So down near the bottom of the screen, I'm going to do 75, the square root of 75. And I'm going to use, let's use 3 and 25 for that one. So the 3 branches done. 25 goes down to 5 and 5. I got a matching pair of 5, so that is going to break down further. 12. 12, I'll use 3 and 4, or use 2 and 6 if you prefer. So the 3 branches done. 4 breaks down into 2 and 2. I got a matching pair of 2s, so the square root of 12 is going to go down further. Next up, square root of 48. I'm going to use 6 and 8. 6 goes down into 2 and 3. 8 goes down into 4 and 2. And 4 goes down into 2 and 2. So I have 2 matching pairs of 2s in the 48 when I look at those circled numbers. So square root of 48 is also going to break down further. Here we go. So I bring down the 3 in front of that square root of 75, leave some room, and now let's rewrite the 75 as 3 times 5 times 5. Bring down the plus symbol and the 2, leave a little bit of room. I'm going to rewrite 12 as 2 times 2 times 3, looking at its factor tree. And here on the end, minus 2 times. I'm going to rewrite 48 as 1, 2, 3, 4 2s and a 3. Just out of room. So I'm going to write the times 3 there below it. And now let's circle every matching pair and kick out one number per matching pair. Looking at the first square root, we got a matching pair of 5s. So 1 5 goes out to the front to be multiplied by the 3 that's already out there. Middle square root, I got a matching pair of 2s. So 1 2 goes out to be multiplied by the 2 already out there. And on the very end, I have 2 matching pair of 2s, so somehow I gotta fit 2 2s. So I'm just gonna write it slanted here, times 2 times another 2. So let's go ahead and keep going with this simplifying. In front, I have 3 times the 5 there for 15. Under the square root symbol, we're left with a 3. Plus, next one, 2 times the 2 in front for 4, of course. We're left with a 3 that's not circled, no matching pairs with it. Minus, sorry, I know the one in black here is kind of hard to read, but I have 2 times 2 times 2 for 8. And we're left with a 3 lurking underneath that square root symbol. It's not circled with anything else. And now that we simplified our square roots, take a look at our square root symbols. We have just the same number of 3 under all of them, so now I'm allowed to add and subtract them. So if I do 15 plus the 4 in front, those numbers in front I'm only looking at, I get 19, minus the 8 gives me 11, and just bring down the square root of 3's, that's what we're counting. So 11 square root of 3 is my final answer. Just be like if in algebra I had 15x plus 4x minus 8x, you would get 11x. Same idea, so now you're just bringing down a root 3 symbol instead of x. And there's my final simplified exact answer. I didn't have to round any decimals there. Taking a look at example 2, it says that police use the formula V equals 2 times the square root of 5 times L To estimate the speed of a car V in miles per hour based on the length L in feet of its skid marks upon sudden braking on a dry asphalt road. Use this formula to solve the following. A motorist is involved in an accident. A police officer measures the car's skid marks to be 245 feet long. Estimate the speed at which the motorist was traveling before braking. If the posted speed limit is 50 miles per hour and the motorist tells the officer he was not speeding, should the officer believe him? Explain. I know this is really wordy, but honestly, you're just going to be plugging into the formula they provide for you. And even better news, you're just plugging into the right side of the formula. So I'm going to bring this formula down. V equals 2 times the square root of 5L. And the first number they give you is the length of the skid mark, 245. So 245 goes into L. Plug it in, plug it in. So that's 2 times square root of 5 is part of the formula, times L is now being replaced with 245. Now that we've plugged into the formula, just simplify down. So I'm going to bring down the 2 that's in front. I'm going to do 5 times 245, that's under the square root symbol, 1,225. Normally, we'd use a good old factor tree to see if we can simplify the square root of 1225, but let's just type it into the calculator just to see if it comes out nicely for a change. So the square root button, remember on the graphing calculator, is above that x squared button, so second x squared, we'll get it onto the main screen. We're doing the square root of 1225. Right arrow key, enter. Yeah, it comes out nicely. It's just 35. We're able to apply the square root to the entire number for a change. Let's go ahead and jot that down. So I'm going to bring down the 2 that's in front. But remember, the square root of 1225 was just 35. So we can say goodbye to that square root symbol since we applied it to the entire number 1225. So it's just 2 times the 35, which gives us 70. V represented the speed of that motorist in miles per hour, looking at the original question. So that means that the motorist was going 70 miles per hour. So the first part of the question said to estimate the speed at which the motorist was traveling before braking. We did that. That was the 70 miles per hour. Now it says if the posted speed limit is 50 miles per hour and the motorist tells the officer he was not speeding, should the officer believe him? Well, no. Clearly he's lying because we've estimated mathematically here that he was going 70 miles per hour, so he was going 20 miles per hour over the speed limit. So definitely the officer should not believe him when you use this formula.